Assalamualaikum and hello everyone. We are from Group Mouse and today we would like to present the project of our group for the algorithmic data structure for the subject code SWC3524, and we have 6 group members. There is me, Muhammad Mazizi bin Mazlan, Nur Adibah binti Muhammad Ruzwan, Nur Farah Adila binti Muhammad Azmi, Nur Syaimah Insyirah binti Muhammad Zamri, Nadia Amira binti Khairuddin dan Putri Nur Syafiqah binti Zakaria. So for the introduction is what is TSP. So the travelling salesman problem, TSP, is a problem that involves finding the shortest route to visit all cities exactly once and return to the starting city. So the objective here is to minimize the total travel distance or cost. Since the problem become more difficult as the number city increase, algorithms are used to find efficient routes quickly and improve decision making in areas such as transportation and logistics.
Hello, my name is Nur Adibah. For the assignment, I'm responsible for the grading algorithm part. For the first is initialization and data setup. This section initializes all the data required to solve the traveling salesman problem. The distance matrix shows the distance between each city, while city name contains the name of the city involved. The visited array is used to track visited city, whereas path and total costs are used to store and travel route and calculate the total traveling distance. The algorithm starts from city A, which is represented by index 0. For the second is stating the starting point. This section establishes the starting point of the greedy algorithm. City A is added to the route and marked as visited to ensure that it will not be selected again later. This step is important because every TSP solution requires a starting city before searching for the next destination. The algorithm will continue from city A to find the nearest unvisited city. Third, finding the nearest unvisited city. This is the main process of the greedy algorithm. The program checks all cities that have not been visited and compare their distance from the current city. The city with the shortest distance is selected as the next destination. This process is repeated until all the cities have been visited, following the greedy principle of choosing the best immediate option at each step. For the fourth, updating the route and the cost. After selecting the nearest city, the route is updated by adding the chosen city to the path. The travel distance is then added to the total cost and the city is marked as visited. The current city is updated so the algorithm can continue searching for the newly location and every city has been visited exactly once. The last is returning to the starting city. Once all cities have been visited, the salesman must return to the starting city to complete the journey. The distance from the last visited city back to city A is added to the total cost. City A is also appended to the end of the road to form a complete cycle. This step ensures that the solution satisfies the requirement of the traveling salesman problem.
Hello everyone, my name is Farah. Today I will explain how dynamic programming is used to solve the. For the first part of the code, we calculate the total number of cities and create a variable called visited all. This variable uses BigMouse scheme to track which cities has been visited. When all cities has been visited, the algorithm knows that the tool is complete. And next, we create a memorization table called memo. This table stores previously calculated result. By storing this result, the algorithm can avoid repeating the same calculation, which makes the program more efficient. A value of minus 1 means that the state has not been calculated yet. Moving to the next sections, the algorithm checks whether all cities has been visited using the condition mouse equal visited all. If this condition is true, the algorithm returns to the distance back to the starting city to complete the route. The next bottom part is the memorization check. If the current state has been calculated before, the algorithm immediately returns to the stored result. This is the key feature of dynamic programming because it avoids solving the same subproblem multiple times. Finally, the algorithm loops through all possible unvisited cities. It calculates the travel cost for each possible route and compares them to find the shortest path. If a smaller cost is found, the algorithm updates the minimum cost and start the best net cities.
Backtracking algorithms is for the first one is distance matrix and cities name. Distance matrix score the distance between cities, whole city name stores to the city labels. And for the second one is the minimum cost. Minimum cost is initialized to the maximum integer value and updated when a shorter route is found. And the third one is best path. Best path stores the shorter route found by the algorithm. So for the next one is initialization, that is set the number of cities, created a visited array, reset minimum cost and best path, and mark city A as a starting point. And then the second one is the backtracking search. Call the recursive backtracking function to explore all possible routes while tracking visited city and travel costs. And then for the result output, after all routes are evaluated, return to the shortest path stored in the best path and its corresponding cost in minimum cost. Next is input and route. This is use 7 parameters to store information such as the current city, distance matrix, and visited cities. And the next one is termination and update. Where all cities are visited, the algorithm calculates the total cost, update minimum cost, and best path if a shorter route is found, and returns the cost. Next, city search. The algorithm checks all the unvisited cities, track the smallest cost, and prevents revisiting cities within the same route. And next, city selection. At that, the algorithm visits and unvisited cities, explores the route recursively, then backtracks to test other possible routes, ensuring the shortest path with the minimum cost is found.
Next, I will explain the implementation of insertion sort algorithm in our project. The purpose of using insertion sort is to arrange the distant value in an ascending order, making the data easier to process and analyze. First, a new array called sorted is created. The value from the original array are copied into this new array. This is important because it allows us to keep the original distance metric while performing the sorting process. After that, the algorithm starts from the second element in the array. The current is assorted a variable called key, while another variable j is used to compare the key with the element on its left side. Next, the algorithm checks whether the elements on the left are large than the key value. If they are large, those elements will be shifted on position to the right. This process continues until the correct position for the key is found. Once the correct position is identified, the key is inserted into the positions. As a result, the left portions of the array remain sorted array of varying iterations. This process is repeated for all elements in the array until the entire array is sorted in ascending order. Finally, the sorted array is written and displayed together with the original array. This allows us to compare the value before and after sorting and verify that the algorithm is successfully organized the distant data. This code shows the main logic of the intersection sort algorithm. The outer for loop goes through each elementing starting from the index 1. The current value is sorted as the key. The while loop compares the key with the previous elements. If a previous element is larger than the key, it shifted one position to the right. After a large element has been moved, the key is inserted into its correct position. Repeating this process for every element, the algorithm correctly builds a sorted array from the left to the right.
Okay, next we use the binary search algorithm to find a specific value in an array. It is faster because it does not check every element by one. A binary search only works on sort array. That's why we need to run insertion sort first before we search. Okay, so first we set two pointer left at the start and right at the end of array. Then the algorithm keeps searching in a loop while there are still element to test. For example, user want to search for the value 30, the program first check the middle value, which is 15. Since 30 is greater than 15, the program ignore the left side and continues searching on the right side. The new middle value is 13, so the target is fine. And then the process is to repeat until the target value is found or there are no more elements and there are no more elements left to search.
And last but not least, for the conclusion, the traveling salesman problem (TSP) aims to determine the shortest route that visits every city exactly once and returns to the starting city. Algorithms such as greedy and divide and conquer are used to solve the problem efficiently by reducing the travel distance, minimizing costs, and finding the most optimal routes possible. So that's all from my group. Thank you so much.